Hey guys, this is Carl, and this is problem number 7. We'll go ahead and dive right into it. What we have here to the left is kind of a breakdown of by class or crew and by mortality, kind of survival rate of a sinking ship. So you have your totals here by crew and class, and the totals here by those who made it and those who didn't. If we draw an individual randomly from this table, randomly select, what's the probability that we will draw a member of the crew? And that's a simple cut and dry answer. What it is just taking the crew total, which is here, 901, and dividing it by 2,395, which is the total of the sample. Actually, the total of the population as defined by the question. So there's a 37% chance. That's what that means. 37% chance of us randomly selecting a member of the crew, regardless of whether or not they survived. B, what's the probability of randomly selecting a third-class passenger who survived? Now, that's a key. First is third-class passengers, and then it's who survived. So what is the probability at random? So there's 135 up here. And of the whole population, the 2,395. So it's the E2 divided by the F4. And you can see it here, E2 divided by F4. So as you can see, there's only a 5% chance of selecting a third-class passenger who survived. So it's kind of a double selection. So that's why the probability here in this case is so low, as opposed to something more broader, as in this question. Part C is what's the probability of randomly selecting a passenger surviving, given that the passenger was in a first-class stateroom. Framed a little bit differently, what this question really means is what is the probability if you pick a restricting to the first-class passengers, what is the probability of picking a survivor? That's really what it's asking. Restricting yourself to what you know as first class only, what's the probability of picking a survivor? And as you can see, what that really is just taking the survivors, 145, divided by the population of first class passengers, 346. So restricting to first class, there's a 41% chance you'll pick a survivor. That's what that really means. And that's really what the question is asking. Part D, if someone's chances of surviving here were the same regardless of their status, how many members of the crew would you expect to have live? So what it is we're taking this value. So the chances of the crew, so it's the F2 divided by F4. We're getting that to survival. This is the survival rate across the board. 26% survived. And that's really, as I mentioned earlier, it's a pretty low rate irrespective of crew or class. And we're taking the crew themselves, the population, this is 901. So 901, it's almost like calculating an expected value. So if that's the case, we would expect, based on our probabilities, that 236 crew members would survive. So that's where that comes from out of the 901. So you can kind of see the difference between observed and expected. And that's really what we're getting at here. Part E is state the null hypotheses we would test here, and the alternative. The null hypothesis assumes the default or the status quo, and the null hypothesis is survival was independent of the status on the ship. They're not linked. Survival and the status on the ship are not related at all. That's what that really means, that if you were in upper class and you're in first class, you were not more or less likely to have survived. That's the null, status quo. The alternative is that they are dependent, which means that if you are first-class passenger, there is an increased likelihood that you are surviving. So just based on this output, based on this data. That's what their hypotheses are. Part F, give the degrees of freedom for the test. We'll do it at 3. So, and as we noted here, the chi-square for the table is 303, and the corresponding p-value is barely greater than 0. So if the p-value is less than a reasonable significance level, reject the hypothesis. So what it is otherwise you fail to reject the null. So based on our analyses, because p, say 0.05, 95% confidence level, if the p-value is less than, so otherwise we fail to reject the null because it is not. So with that case, that means that there is a strong relation, there is a measurable relation between class size, or class itself, like first class, and the survival rate. So really that's what we're getting at here. So we just hope this helps. Just let us know if you have any questions along the way. Thanks so much.